Alright, let's take a look here. This section is 12.4 and the I can statement is I can raise monomials to a power and simplify using the power rule. So this is the power rule for exponents. And we're going to start by reviewing some skills with exponents that you should have already. So let's run through and take a look here. We have 2 to the 11th times 2 to the 14th. So we're going to use the product rule for exponents here. So if the bases are the same, the base stays the same, and we add the exponents together. So we have 11 plus 14. 11 plus 14 is 25, and we're just going to leave it like that. When we multiply these two expressions together, you'll notice that we've got a coefficient here and a coefficient here. So let's take care of the numbers first. Negative 5 times positive 5 is going to be negative 25. And then we've got m to the 5th times another m to the 5th. So when we're multiplying these, just like we did here, the base stays the same. So this is going to stay in m, and then we have 5 plus 5. So that's going to be 10. So there's our answer on that one. You'll remember that a negative in the exponent means reciprocal. So we're going to take this and we're going to move it from the top where it is right now. We're going to put it on the bottom. So that's going to be y to the 6th. And remember, once that's done its job, once it's moved it into the denominator, once it's done the reciprocal part, that can go away. It's done its job. It's down there in the bottom. And then 1, you'll remember, is part of any multiplication problem. So there's a 1 left on the top. So we have 1 over y to the 6th on that one. Let's take a look right here. We have several things multiplied together. We're going to take a look at this right here. That's z to the 0. You'll remember that most people, if they say, if you've got a number raised to the 0 power, the answer is 0. It's not. Remember, any number raised to the 0 power is 1. So this is just a big fat 1 that's left right here. So we have 1 times all of this stuff. So that's not going to change anything. So I'm going to take care of those coefficients right there. We're going to multiply the numbers together. We're going to get negative 24. We only have this one x expression, so this is x to the 5th, and notice that we've got y to the negative 7. The negative in the exponent means reciprocal, so we're going to move that down into the denominator. The negative's done its job when it moves down there, so that's not a negative 7 anymore, it's a positive 7. So there's our answer on this one. We'll take a look at this one right here. The first thing we notice is we have a negative exponent. So we're going to move that into the denominator. So we're going to do the reciprocal of that. So we have the 6 on the bottom. So we're going to have x to the 6th on the bottom. And then we've got 3y's on the top and 4y's on the bottom. This is the way I prefer to do this. These 3y's are going to cancel with 3 of those. So there's 1 left, and it's on the bottom. So recall again, there's always a 1 left in any multiplication problem. So this is the answer right there. I am going to show you another way to do that one. We could simplify the y's first, so I'm going to leave that as x to the negative 6, and then using the quotient rule for exponents, you subtract the bottom exponent from the top. So this would be y to the 3 minus 4. So this is x to the negative 6. Y to the 3 minus 4 would be negative 1. Now they both have negative exponents, so we're going to move this one into the denominator. So that's x to the 6th. We're going to move that into the denominator. You could put x to the 1st if you wanted to, but it's certainly not necessary, and we normally don't. And then again, there's always a 1 left in any multiplication problem. So there's our answer right there, 1 over x to the 6th y. And then we're going to come over here and we're going to take a look at this. I'm also going to do this one 2 different ways. So let's take a look right here. Let's go ahead and cancel the coefficients here. 3 goes in here once, 3 goes in here 5 times. So we have a 5 left on the top. I'm going to cancel these guys here. 6 on the bottom, 10 on the top. 6 are going to cancel. There's 4 left, so that would be x to the 4th. 3 on the top. These are x's also. 3 on the top, 8 on the bottom. 3 are going to cancel, so that means there's 5 left. And then we still have a little bit more simplification to do. So what we're going to do is we're going to say these 4 will cancel with 4 of those, so there's only 1 left. So the answer should be 5 over x. Now, I'm going to do that a different way. I'm going to come back here and I'm going to erase these, and we're going to simplify the numerator and then simplify the denominator. So here's what we get. We get 15 x to the 10th times x to the 3rd, that's to the 13th. We add the exponents. Same thing in the denominator. We're going to add these together. 6 plus 8 is 14. So this is going to be x to the 14th. Oops, make that look right. So this is x to the 14th. Let's go ahead and cancel those. So that would be a 5 on the top, and then we've got 13x's on the top, 14x's on the bottom. So that means these 13 are going to cancel with 13 of those, and there's only going to be 1 left. So we get the same answer either way. Either approach is fine. Probably best to simplify the numerator and denominator first. That's probably a better way to go in the long run. So let's take a look and kind of remind ourselves of some of the things that we've been learning as we've been going through working with exponents. When we multiply expressions with the same base, then what we ended up doing is we ended up adding the exponents. So when we multiply expressions with the same base, we add the exponents. When we divide expressions with the same base, got to be the same base, then we subtract the exponents. So if you think about the operations that we use in math and the way we learn them, we learn how to add, then we learn how to subtract, then we learn how to multiply, then we learn how to divide, and then we learn about exponents and powers. So when we're multiplying expressions with the same base, we end up adding. When we divide expressions with the same base, we end up subtracting those exponents. So if that pattern holds, what do you think we do when we raise a power to another power, when we have an exponent raised to another exponent? Well, you'll notice that we kind of drop down 2 levels here and drop down 2 levels here. So we kind of drop down 2 levels here. So when we raise an expression with exponents to another exponent, then we multiply the exponents. So go ahead and write multiply there. And we're going to take a look at a couple problems, and we're going to show why this rule works the way it does, and then kind of summarize and do a couple problems. So when we have x squared raised to the third, that literally means this is the base and we're going to raise it to that power. So this is going to be x squared used 3 times. So we're going to have x squared times x squared times x squared. Well, now this is a multiplication problem. It's a product. So we're going to add the exponents. So this is going to be 2 plus 2 is 4, plus another 2 is 6. So this is going to be x to the 6th. We'll come back and check that in just a second. So this is 2 to the 5th raised to the 4th. So we have to write 2 to the 5th 4 times. And then let's check and see. Base is all the same, so the base is going to be 2. And then we have 5, 10, 15, 20. We're going to add all of those up, so we have 2 to the 20th. And then on this one, we have 4n to the third. Notice that's in parentheses. Actually, all those are in parentheses. Take a look at that. And we raise that to the 5th. So this is 4n to the third. We're going to write this down 5 times. And you can see why mathematicians like to find shorter rules and shorter ways to do things as long as they're getting the right answer. So let's count them up. 1, 2, 3, 4, 5 4s. So this is 4 to the 5th. And let's see, 3, 6, 9, 12, 15 n's. So n to the 15th. And here I want to show you a little general rule that we're going to use, at least in this class. We're going to say if the number in front of the coefficient is more than 1500, then we're just going to leave it in exponential form. So let's grab the calculator and let's check and see what we've got here. If we do 4 to the 5th, so let's do 4 raised to the 5th power, so 4 and then the caret button to the 5th power. My calculator may look a little bit different than yours, but let's see, so we get 1024. So we're going to write 1024n to the 15th. So let's come back here and take a look, and let's make sure that this rule would actually work. So we did this by expanding every one of those, and that's a kind of a pain in the butt. Let's see if we can actually use multiplication with those exponents and get the same answer, and take a look. 2 times 3, this is a power raised to a power. 2 times 3 is 6, so we got that one right. 2 to the 5th raised to the 4th, that power raised to a power, so we're going to multiply these. 5 times 4 is 20, so we got that one right. And then if we wanted to put an exponent on here, don't forget that there's a 1 there, so this would be 4 to the 1st to the 5th. So we're kind of like distributing here. 5 times 1 is 5, and then 3 times 5 is 15. So we did get this right. This actually works. So let's write this down in kind of a compact format. Let's write a little formula. So we've got the base raised to a power, and then we've got that in parentheses, and it's raised to another power. So we have a power raised to a power. If that's the case, then what we do is we just multiply the exponents. So this is often called the power rule for exponents. So that's what we're going to use today. And what I want you to take a look at is those problems there, and each one that we do here, you have to have parentheses in each one of these problems. Whenever we have a power raised to another power, it will always have parentheses. Okay? So we're going to run through and we're going to do these problems, and then we'll see how quickly we can get you working on your assignment. So we've got a power raised to a power. The base stays the same, and we multiply the exponents. So 2 times 6 is 12. I'm going to circle that. You're welcome to plug that into your calculator. That is a gigantic number, so we're not going to worry about changing that. We're just going to leave it in exponential form. Let's take a look at the next one. The next one is negative 2y to the third raised to the fourth. Now, you'll notice that this is negative and it's inside the parentheses, so that really means we have 4 negatives, 4 2's, and 4 of these guys right here. So I'm going to put that in parentheses, so negative 2 raised to the fourth, and then this is going to be y to the 3 times 4 is 12. Now let's take care of this number right here. If you type this in your calculator wrong, it will give you the wrong answer. If you type negative 2 and then you raise that to the fourth and you don't put it in parentheses, it's going to say the answer is negative 16. But remember, we have 4 negatives. 4 negatives, that's an even number of negatives, so the answer should be positive. So let's put that in parentheses, negative 2, parentheses, and then we're going to raise that to the fourth. There's our 16. So 16 y to the 12th, and we're going to go ahead and circle that. So careful with those negative coefficients and raising them to powers. So then we're going to take a look at this one, same type of thing, negative 2 raised to the 7th, y to, this is actually easier with the variables, to the 21st. And again, you'll notice we've got 7 negatives. That's an odd number of negatives. We should get a negative answer. We'll check this right here. I'm just going to recall that. Change the exponent to a 7, so I've got negative 2 raised to the 7th power, and we get negative 128. So negative 128, y to the 21st, and there's our answer on that one. This one has more variables, but as it turns out, I think this is a little bit easier. Again, it's kind of like distributing this through. We've got y to the third raised to the fourth, power to a power we multiply, so that's going to be x to the 3 times 4, that's a 12. Power to a power, we're going to multiply, so that's 2 times 4, that's 8, and we are done. That's it. That's all we have on that one. X to the 12th, y to the 8th. So let's take a look down here at this last row, and we'll see how quickly we can get done with those. We're going to raise each one of these to a power, so this is going to be 6 to the third. Again, if you want to think of that as a 1 there, that would be fine. M to the 5 times 3. 5 times 3 is 15. N to the 4 times 3 is 12. And then let's check this number. You may recognize that. We've got 6 raised to the third. So we'll do 6 raised to the third. 216. That's on our list of perfect cubes. Hopefully you've got those memorized. 216, m to the 15th, n to the 12th. And we're done with that one. That's under our threshold of 1500. So let's take a look at this one. 2 negatives and 2 5s. So that's going to be negative 5 squared. That's going to be a 25. X to the third to the second, power to a power. So that's going to be x to the 3 times 2. That's a 6. Y to the 7 times 2. That's a 14. And we are done. That's it. They're that quick. So let's take a look at these last couple. Again, if you want to think of the 1, that would be fine, but we can just write 5 to the 6th. If you want to use parentheses on that, that's fine. It's definitely needed when we have a negative. When we have a positive, not so much. So this is going to be u to the 6 times 6, 36. V to the 5 times 6, 30. Let's go ahead and check this one on the calculator. Let's see how big that is. So we're going to have 5 raised to the 6th power. 15,625. So we're going to go ahead and leave it that way. It's almost nice when it turns out to be those big numbers. And then we've got this last one right here. 6 raised to the 5th. J, 6 times 5, 30. K, 2 times 5, 10. N, 4 times 5, 20. And if you want to check that on your calculator, 6 to the 5th is a huge number. So we're just going to leave it like that. We're going to circle it, and we are done. So I'm going to pause for just a second. I'm going to give you a minute to grab your worksheet, and we're going to do a couple problems from the worksheet. If you don't feel like you need some extra help in practice, you're welcome to go ahead and do the problems there. Just maybe glance up every once in a while and make sure that you are getting the right answer. We'll do a couple of them, and then we'll just turn you loose on the assignment. So here's the worksheet, and we are going to do problem 1, 5, 8, and I think we'll do 12, and then we'll take a look and see if we need to do any of the others. Again, easy problem like this, single base raised to that power, and that whole thing's raised to another power, so the base stays the same. Multiply the exponents. 5 times 3 is 15. If you would like to check that on your calculator, let's just check and see if we should write that out as a number. So 2 to the 15th, 32,768. 32,768. So we're just going to leave it in that exponential form right there, just 2 to the 15th. Take a look at number 5. 4 raised to the 3rd. N raised to the 5 times 3, so that would be 15. So let's see here. Hopefully you recognize that one, 4 to the 3rd. You can do that on your calculator if you've got that one memorized. That's on our list of perfect cubes. So that's 64n to the 15th. We're going to circle that. I'm going to give you a little bit of a head start on this one. Notice the negative. Two negatives and two fives. We'd have negative 5 squared. That's going to be positive 25. And then w to the 4 times 2 to the 8th. And then the last one we'll take a look at is number 12. Again, give you a little head start. It's kind of like distributing here through to all of these. 6 to the 3rd, x to the 3 times 3, 9, y to the 6 times 3, 18, and again I think we've seen that number before. That is 216, so definitely under our threshold, and then we'd have x to the 9th, y to the 18th. Circle that and we're done. If you have any trouble with any of these other problems, you may want to look at some of the examples that we did in our notes. In particular, you may want to take a look at number 24 and see if that looks familiar. So hopefully that helped, and good luck on your assignment.